Okay, hey, train your plants every day. Jordan School coming at you from the STEM lab this morning. Now, I want to continue some of my quantum physics lecture. Not necessarily the quantum mechanics game that I was doing. Just process out information. Just getting ready for probation this morning, and I got a few extra minutes to kill here. So, I wanted to actually go ahead and talk about some of the nature of quantum physics. Firstly, as quantum physicists out there, first thing you have to remember is this is a planet where organisms eat other organisms every day. Alright. But that doesn't always make you the smartest person in the world. It's one of those things, why aren't you in charge? Why don't we have a quantum physicist in charge? Right? It doesn't matter this country, that country, all countries. The number goes to a unified system. Kind of goes against a lot of this thinking of a thing. Without going too much down that rabbit hole, just because you're smart doesn't necessarily make you not that kind of predator out there just the same. And again, a lot of that kind of way of thinking about a thing screws a lot of stuff up. I find myself somewhere in the middle of all that, well-rounded as it were. Anyways, I just want to throw that notation out there. Just because you got a nerdy person out there doesn't necessarily mean that they are. You gotta be careful. A lot of the stuff in quantum physics is oversmarting the system. Newton, Einstein, later on when we find out those theories, those classical models, which again we're going to get into that idea later, won't work out so well. And a lot of them are zeroed out. You can't really use the law of gravity for anything because it's a particle. And when you go to try to measure that particle, it only becomes a wave function principle. Just this at the speed of light, 0. But if you try to measure the wave function, or I forget exactly how that's worded out, that all the mechanics start to break down. That you can't use gravity equals, well, this equation. And you can't just process those numbers, m1, m2, over radiant squared. You can program a radiant squared. You can program m1 and an m2, but only invertly will it equal gravity. And it's not going to give you exact numbers, and those exact numbers aren't going to be very specific to gravity in general. So when you go to measure that, it's all going to break down. Alright, so that kind of idea is important. It's like looking at trigonometry in general. Alright, so it's a chemical reaction by classical mechanics. That's where you're at. Now, obviously, if you're I forget who he is. He played in Zoo or whatever it was there, and he's Jason Bourne, right? He plays in this Mars movie, and he's a botanist, but he needs to know chemistry and all those things. Basically, they're doing standard classical mechanics, right? Just physics, classical physics. Well, in a lot of that there, you're not using black holes, you're not using all these ridiculous principles, but time dilation is an important thing to know. It's the particles of where time dilation breaks down. Is we measure this in wavelengths of portions of sizes like this, which become particles that break down. We can't really use it, and the study of it isn't really practical by that standard. You're using classical mechanics to understand that, and you can do it in the same regards. So again, a lot of these guys kind of are predators for what they are. It's in the game of survival. Organisms eat organisms every day on this planet, just the way it is. Choose one model of survival that's not all models of survival in a self-contained system, 0, gravity, you're not really doing it right. With that being said, we live in this planet with all of that, and we have to contend with that. So it is important to understand kind of both sides of this principle. But there's something I want you to do for your homework assignment today. Go out there on Facebook. I know this one kills me. I was recently and I typed in quantum physics to the heading to the search bar on Facebook that I wanted to look up. You can do any other version of it you want. Now again, I find a lot of psychological quotes and things like that I agree with. Now again, not all of them. Sometimes I don't agree with always the way Einstein propagates these decisions, or I'll agree with Planck variation of it that's very psychology. Once you start looking at a thing, the way that thing acts begins to change. You look at a cheeseburger. Not only is it a cheeseburger, but it's a pickle farm. And you look at all the points on a pickle farm. They're their calculus, their inventories, their those wave functions that can't really be measured by the standard unless you're looking specifically, and that specific answer doesn't satisfy the Big Bang. Cheeseburger, restaurant, business model, resume, application for a worker, and whatever they could use that for. You're not just a worker at a McDonald's. You're a quantum physicist. You just don't understand that because you haven't changed the way you're looking at that thing yet. That's a particle that begins to break down that can't really be measured by that standard. There's a lot of other principles of quantum mechanics that I agree with. I like those ideas, but they more work metaphysically or parapsychology in this idea. So go on your Facebook and check out a bunch of different quantum mechanics. There's one that's got a little picture of Schrodinger's cat in it. That's the one I got a lot of them off of, those quotes that I actually really like. But again, when you look at the mathematics now, black holes are apparently optical illusions. There is no Big Bang. There's new ideas of the Big Bang of not really being ever having a start, that the universe always was. And that goes against all these classical ideas that we understand and that we use. At this point in this conversation is the beginning of a Big Bang, essentially a new universe, a new element acting into other elements. It works in both regards. But there's a quantum physicist out there saying this thing is going to screw everything up. There's a classical person over there who's going to fight that guy's standard of screwing not only that person up, but every avenue under that, because it still applies to classical mechanics. And why aren't you in this house? Because I want to do it over here, and I believe that that's a different element because those parts over there, and I call it whatever the hell I want. I want those kind of ideas to be relative and apparent here, because a lot of them, if you really understand and you study quantum mechanics and even psychology to a little bit here, that they're not really practical. Again, algebra is another one of those really good ones. Where does x2 begin? I have x number of Macintosh apples and x number of, you're basically doing classical physics, classical mechanics. 2 plus 3 equals 5. 2 minus this equals this. And then I'm putting it in the parentheses or a group that has to be multiplied first. When does that really ever apply? Think about it. As a teacher, one of the hardest things to do is actually specify a psychological special relativity notation to the question that you have. Now, it's easy once I know here's the core model that somebody already worked up, and I'm just going to change out the height of the tree or the length of the shadow and therefore the time. And I might give you the time and I might give you the length of the shadow, and there's a simple trigonometry algebraic variation of what's going on. Algebra needed to be trigonometry here by the A's, the B's, the X's, the Y's, and the principles that go against classical physics or classical mechanics. But it's basically a chemical reaction. Once those in that standard, it's great. I can separate all of those things, but again, it's only going to be relative to that point in time, and it's going to change. It still has a very fundamental fractal position at the decimal level that's constantly changing. We only generalize that group. See, X, Y's, and Z's, and the trigonometry, this tree, that tree, where you might be standing starts to break down this particle. Can't really be measured. Once I know that weight, I can't determine it as that particle because it's a wave function based in the spectrum of light and gravity and all these other dealios. So one of the hardest things it is to do is to reference a psychological answer or question. Answer being the question. That is the particle, that is the wavelength of these examples. You can do it with this, each state, each concept of a state, what variation is quantum mechanics, but at the end of the day, it's that small a mechanics that references every variation, even when I sub that out to number theory of prime functions or overlapping grid state, how like composite systems, and the Pythagorean theorem, if you will, when you start adding those states on top of each other, on top of each other, on top of each other, that really get away from finding a universal simplistic equation that generalizes this. I'm going to war weighing a resistance with Newton, general or gravity, Planck, that says I know those spectrums work great, but are they relative? Are they? Now, relativity is not general relativity. It's a term. It's a term we use. It was a term that was had that now became such a large mathematics base to it that it's not necessarily practical. Okay. So go ahead and check out some of that stuff and really read if it makes sense. In one part of it, it will. It's a very active weighted element. You're going to say, well, here's that example or that form of a string or a boson out there that might make sense to you, but they're going to apply it in a mathematical form that's not really relative. A hadron collider, satellites, and things that are making sense of stuff millions of billions of millions of miles away in cosmetology and astrology. And it may not be relative to you, so you really have to take those things into consideration and ask yourself, what is a better question for those answers? Because that's what they're going to say. Don't be afraid to take their work and better apply it here, where they should have been doing this work. It's one of those things I'll tell you. Because you could be a quantum physicist too, by their standards. But I'm basically going to tell you what you're going to be doing is basic physics, is classical mechanics, and a lot of other mechanics. Just fixing the problem or building a problem. And again, there you have those two particles, those two states, where fixing a thing is building a thing. It's building a thing by fixing it, in this space-time problem. Again, now black holes are illusions. The speed of light has changed 80 different times. I even heard that there's a new form of light. Visible light, microwaves, ultraviolet, and now there's another one. Well, what the hell was wrong with all the other standards? And I mean, what can you possibly do by those new standards that is going to make a grocery store's barcode scanner more efficient? It's already pretty damn efficient. They don't mess up all that much as long as you don't fuck up the inventory, which still you're going to have that problem with. Honestly, the supercomputer that you hook that up to isn't really the problem. Google Chrome. Alright, Google, they got a new super quantum computer that they said moves 10 times faster than, the classical computer they had. I didn't have really that hard of a time. I don't know what everybody else is doing with this material. I don't know why I'm trying to use Google through all these variables for web searches like that anyways, but I really don't have all that kind of a problem with it. I don't understand what you are trying to process. What are they trying to process there at Google? What are they trying to build? What are they doing with this concept? What would you need to do to be at that kind of platform with a thing other than a basic designer, or even building your own little mini hadron that you would need that kind of computer computations for? Believe me, I understand this calculation. This is just the opening statement. That'll run infinitely. That'll run to infinite group states under that standard, which this is going to apply against. This is going to start to AI out that variable by the A mechanics, I irrational numbers that I start applying those variables to, which only still work because I have some basic stuff programmed in here. And if you don't program those supercomputers, it's not going to apply correctly. If it doesn't have a handler base to it, well, they're just going to take over. I get it when it's in a toaster or something like that. Alright, fine. But what you're asking it to do really isn't practical, isn't an applied model of what is sensible to the majority of the people here. Again, the numbers go up, but as the numbers go up in population, a great one in science is for every problem you solve, 10 more are created. That's quantum mechanics. That's quantum physics for you. That's actually understanding classical mechanics as well. As you solve a problem, now I have to solve that problem against everything I've already worked out, because it's going to potentially be a faster answer to all those states as well. So I know that answer is a problem. Now I have to do that instead of these classical models of, hey, look, we just process this is what this is. It's not very sensible to go too far down the rabbit hole. Ignorance to a certain extent is bliss. If you're working at that McDonald's as a quantum physicist, making cheeseburgers, it's going to eat you alive because you know these numbers. And you're going to have to process them. And you're not going to be able to achieve those things. It does help. Perspective is a lot of things, but if you don't have those inventions or those states to go with it, it's not going to make much difference. You're not going to be a billionaire today. It's one of those things I have to break the reality to you. You might have time, you might have space, you might, but you don't have materials, you don't have concepts. This is what you have to build. There's the answer to the problem. There's the problem. Catch you on the next one.